In this video, we're going to take a look at the formulas of acids and bases, and how can you tell when you're looking at a chemical formula whether it is an acid or a base. So the first thing you need to know is that when you put an ionic compound and dissolve it in water, that causes the cation to break apart from the anion, and then that cation and the anion just float around freely. Okay, so dissolving. You should be taking notes on this stuff, by the way. Example. If you take table salt, that's NaCl, and you put it in water, the cation is the sodium with a plus. That will float around on its own. It's aqueous, that means it's dissolved in water. And the chloride will float around on its own, aqueous as well. So ionic compounds, they break apart. Before it's dissolved, it's a whole bunch of sodium atoms bonded to chlorine atoms one by one. Sodium, chlorine, and they're all in this big crystal. But all that breaks apart, and after it's dissolved, the sodium ions can float around freely in the water. Same with the chloride ions. Second thing you need to know, definition of an acid. You may have heard this before in my class. An acid increases the concentration of hydrogen ions in water. So that's an acid. You dump it in water, and just like the table salt, it's going to break apart. But one thing that happens when an acid breaks apart is that you get more H plus in the water. So maybe you, just thinking ahead a little, if you want an acid, if you want a chemical to be an acid, instead of this Na plus, you would make a chemical where this would be H plus, because if you dump something into water that splits apart and makes H plus in water, well, that's the definition of an acid. A base, so I'll get to those examples in a moment. A base is really similar. But it's not hydrogen ions this time. This time it's OH minus, which is the hydroxide ion. And so similarly, you can imagine that if we had an ionic compound that had OH in it, when you dump that in water, the OH will split off from the compound and freely float around, and that would be a base. And you would be right for thinking of that, okay? Now, an interesting thing to note, side note, before I get to those examples. If you put an acid, that's H plus, together with a base, that's OH minus, you get something with two H's and an O, which is H2O, and of course H2O is water. So acids and bases, they're each 1/2 of water, and that's interesting. Okay, so let's look at some examples of acids. Example acids. Okay, HCl. That's very similar to what I put up above. NaCl was salt. The acid would be HCl. If you put that in water, it's going to break apart into H plus and Cl minus. And that's our definition of an acid. Anything that creates that H plus in water, that's what an acid is. Other examples, HNO3 is nitric acid. Same thing, this can split. There's H2SO4 is sulfuric acid. H3PO4 is phosphoric acid. There's a whole lot of them, okay? Doesn't matter that there's a 2 or a 3 on the H. The point is it begins with H. And that's how you tell. Acids begin with hydrogen. Bases create hydroxide in water. So, as you can imagine, they need to have OH in the formula. So NaOH would be a common one. Notice that with a base, the OH isn't in the beginning, it's at the end. That's because OH is a negative anion, and the anion always comes second in the formula. We could also have calcium hydroxide, aluminum hydroxide. Anything hydroxide is a base. Okay? There's one tricky base you need to know about. Actually, we'll write this down quick. Bases and with OH. There's a tricky base. One that doesn't end with OH, but it's still a base. It's an exception. There's always an exception in chemistry, right? That would be NH3. Okay? This is called ammonia. When you put ammonia in water, it does this tricky special thing where it will steal one hydrogen atom from the water to become NH4. This is ammonium. Well, when you steal a hydrogen atom from water, what you're left with is just one H and an O. Well, that's hydroxide. That's OH minus. So you see that when you put ammonia in water, it does increase the concentration of hydroxide in the water, even though it doesn't have hydroxide in itself, because the hydroxide comes from the water itself, and ammonia is special. So bases end with OH, and there's NH3 that you got to watch out for. And basically that's it. You just need to watch out for things that start with H or end with OH.